So what did you do in last class?
We have done the electric current, Aisha. We have done electric current. Did you miss the last class?
Yes.
कोई बात नहीं. So you can watch the recording. If you have any doubt, please let me know. Okay.
Okay.
Hello, Zainab. Assalamu alaikum. How are you? Zainab, am I audible? Okay, everyone. So let's start the class. Everyone, please switch on your videos fast. Uh, Aisha, please check your camera. Your video is not visible. I think so. You have selected another camera, so please check it. Like it should be integrated camera, whatever camera you are using. Please select that. Zainab, are you there? Zainab? Okay, so I think so she has some network issue or
Yes,
mic
sir.
issue maybe. Yes, Zainab, how are you? Assalamu alaikum.
Walaikum salam, sir.
Okay, that's good. Please switch on your video fast, everyone. Okay, so let's start the class. Okay, everyone. So in the last class, we have completed the electric current, right? So in the last three classes, first class we have taken the electric charge, second class we have taken the potential difference, and the third class we have taken the electric current, right? So in all these, basically these are the three fundamentals quantities that we've used in the electricity chapter so far, and we've studied about them, right? So so these are the three quantities that you will be dealing with throughout this chapter, right? So you don't have to there is no other quantity that will be there except current, the potential difference, and the charge, and the time as well. Another quantity is time. So basically, so now we have completed the basic things. Now we are going to study about the Ohm's law. So Ohm's law is basically a law, basically which establish a relationship between the current and the potential difference between the 2 points. Right. So in this, we are going to study what Ohm's law is and what are the factors affecting the Ohm's law and what is basically the you can say what are the consequences of the Ohm's law, right? In the electricity chapter. Is that clear so far, everyone?
Yes.
Chalo, that's great. Okay. Now let's understand this thing. So basically, in the simple words, if I say Ohm's law, so Ohm's law states that the potential difference is across the points is directly proportional to the current flowing through it at constant temperature. It means that potential difference is directly proportional to the current flowing through it. Is that clear? In simple words, Ohm's law states that the potential difference is directly proportional to the current. What does it mean directly proportional, everyone? Zainab, Aisha, and Mariam. Sorry, Alvina. Is there anyone who knows
It's
the
like if one increases, the other also increases,
okay, Zainab said
and
this.
one
Okay,
decreases, the
Zainab.
other also increases. If
Okay,
the other
Zainab.
also decreases.
Okay, that's great. What about the rest of you, Aisha and Alvina?
Yes.
Yes, sir.
Any answer about the directly proportional word? Anything that comes to your mind when you hear the directly proportional word?
No.
Okay. Alvina?
No, it's the same answer, sir. If one
ठीक है.
increases, the other increases as well.
Okay, okay, that's great. Okay, so yeah, Alvina and Zainab gave the right answer. So basically, directly proportional in simple word means that they are linear. It means that if one increases, the another one increases automatically, right? So let's write down the statement of the Ohm's law, everyone. Okay. Potential difference across conductor is directly please rename yourself. What is the name? The new
Sorry,
student
sir,
has
sorry.
joined.
Sorry,
Yes,
sir.
Mariam. Yeah, because that will create a little bit confusion, na? So that's why.
Sir, I
Okay.
joined through link, that's why.
Okay, no need to worry. I'm renaming them. Okay, okay, you have renamed
Sir, I
yourself. That's
renamed.
great.
Yeah.
Okay, okay. Okay, so this is directly proportional to the current flowing. It seems like students are thinking that after the midterm there is a vacation. And still like you can see the strength of the batch right now. Only 4 students are there. And the same thing happens in the another batch. 4 students were there, and the strength of that batch is almost 8 or 9 students. And only half of the students are joining. It seems like students are thinking that there is a vacation after the midterms and they are enjoying and chilling. That is not the case, huh? So the syllabus will be going with the same pace that we were doing in the last basically term. So please do not miss the classes, okay? Flowing through a conductor. And everyone, it's a request. Please join on time, okay? Conductor at constant temperature. This is a very important thing, at constant temperature, because if you do not write it, Ohm's law will not be valid. The accuracy of the Ohm's law is all about the at constant temperature. Okay? I'll let you know why it is very important. Okay. So the potential difference across the ends of a conductor is directly proportional to the current flowing through it through a conductor at constant temperature is called Ohm's law. This is the statement of the Ohm's law. If question comes into the exam that state Ohm's law, so you have to write this definition in the exam, and you have to write this thing as well. See this. Okay. So as you can see, the statement says that V is directly proportional to I, yes or no? So it is directly proportional. So, and if you remove this proportionality sign and basically substitute the equality, one constant will get introduced, that is called the resistance. R is a constant that is called resistance of a substance. Is that clear? Please do let me know, everyone.
Yes, sir.
Yes.
Okay. And R is equals to everyone, this chapter is all about the previous the thing that we have done so far. That is all there in chapter that is required to understand the further topics. So it's a request, whenever you come into the class, please give at least 30 minutes to the topic that we have covered in the last class. Right, from now onwards, please make a habit of that, because if you do not revise, you are not going to understand at all. Clear, everyone? Okay. And one more thing, I will be taking a Viva from now onwards for the electricity chapter. Whatever will be doing in this class, I will be taking a Viva, 15 minutes. Okay. And I will basically share the report to your parents of the same. Okay. So it's a request. Please and please do the revision. Okay. Because if you do not, you are not going to understand this chapter properly. Okay. So it's not about, it's not like light chapter, human night chapter. It's a complete different chapter. Okay. Now, see this thing. So the next, so this thing that is basically your, that is R. So your R is basically a constant that is called the resistance of a conductor. Okay, R constant called of a conductor. Okay, B point. Now, now as you can see this thing, everyone, that after this Ohm's law statement, you can see this thing R is nothing but the ratio of the potential difference across the 2 points and the current flowing through it, yes or no? And one more thing, everyone. If this is constant, it means that R is not going to change in a specific scenario. It means that V and I will adjust accordingly so that the R is constant. Similar, if you remember one thing that the refractive index is the ratio of sine I by sine R. So refractive index was constant and angle of incidence and angle of refraction was basically adjusting accordingly. If the angle of incidence was something else, so angle of refraction will become such that the value of the refractive index remains constant. Yes or no, everyone?
Yes.
Please do let me know. Clear, yes or no, everyone?
Yes.
Okay. So that's why R is called constant in the you can say in the Ohm's law statement, right? And the definition of this R in terms of V and I, let me write it over here. The ratio of potential difference applied between the point ends of the conductor the current flowing through it. Constant quantity called resistance. Clear, everyone? Please do let me know. Is that clear to all of you or not? So this is the definition of resistance in terms of the current and the potential difference across the 2 points. Yes or no, everyone? Okay. Now, sorry. Okay. So one more thing. Okay, now see this. Now C point comes into the scenario that is the effect of current due to the resistance of a circuit, resistance of a conductor. Okay. So now let's understand. See this thing, everyone. That can I write this thing I is equals to V by R from the equation V is equals to IR. देखो, V is equals to
Yes.
IR. So can I write I as V by R? Yes or no, everyone?
Yes.
So from this, you can see this thing that current is directly proportional to the potential difference. That is right according to the Ohm's law. That's what we have said right now. Yes or no? The current is directly proportional to the
Yes.
potential difference or vice versa. Right? If I'm saying current is directly proportional, so you can also say that the potential difference is directly proportional to the current. So both are the same thing. It doesn't matter, right? So don't get confused that if somebody says that is whether the statements are correct or not. If the current is directly proportional to potential difference or potential difference is directly proportional to current, both are same. Is that clear so far? Please do let me know.
Yes.
Okay? Yeah. So now as you can see this thing, current is directly proportional to the potential difference of a conductor. Okay? Just a moment. It means that if you increase the current, potential difference will increase, or vice versa. If you increase the potential, the electric current will also get increased. Okay? the potential difference. I'm writing in short form, that is PD. Okay, potential difference. Clear, everyone? Next one. The second
Yes.
point. The second point is current is inversely proportional to the resistance. It means that current will increase if the resistance is decreased. Inversely proportional. It means that if the fraction is decreasing, if the denominator is decreasing, the fraction will increase. Yes or no, everyone? And if your fraction denominator is increasing, so your ultimately the fraction will decrease. Is that clear to you, yes or no, everyone?
Yes.
Zainab,
Yes.
Aisha and Albina?
Yes, sir.
Okay, that's great. Okay. It means that the current resistance. Okay. So in simple words, if I say this thing that if you increase the potential difference, the current, if in simple words, if I say that if you double the potential difference, what will be the effect on the current? Why, by what factor the current will get increased? Please do let me know fast.
Sir, can you repeat?
Can you
I'm
repeat?
saying that I'm saying that if I increase the potential difference by a factor of 2, so what will be the effect on the current?
It will
Yes or
also be
no?
2.
Will also,
It'll also decrease with the same.
I am saying if I increase the potential difference by a factor of 2, what will be the effect on current? Potential
The current
difference.
will also be increased by 2.
Okay, Alvina said increase by 2. What about the rest of you? Aisha and Zainab?
Can you repeat once more?
Okay, no issues. I am saying that if I increase the potential difference by a factor of 2, it means that if I double the potential difference, what will be the effect on the current?
The
It will
current
decrease.
One
will
by one.
also
Okay, Aisha.
be doubled.
Okay, current will get doubled. Yes, Zainab, now tell me.
It will get doubled.
It will get doubled. Yeah, that is right. Because we have said now directly proportional to the potential difference. It means that if you double the potential difference, current will also get doubled in that case. Okay? If potential difference inductor is doubled, the current flowing also get doubled. Okay? And if I basically decrease the potential difference by half, what will happen to the current?
The current will be also.
Current will be half. Yeah. So current
Yes.
will also get decreased by half. Okay? Potential difference is directly proportional. Now, everyone, if I basically decrease the potential if I decrease the resistance by half, if I decrease the resistance by half, what will be the value of current?
It will increase by what?
I'm saying that if I decrease it by half, what will be the effect on the current? Half or what? The number, factor. Zainab,
Maybe
Aisha, Alvina. Okay, Alvina said half. Zainab.
half.
Okay, Aisha.
Sir, not half,
Can
it
you
will
repeat
be
the question?
1.
Yes, okay, I just one by one, one by one. Aisha, please complete what you are saying.
Sir, can you repeat the question?
I am saying that I have decreased the resistance by half. What will be the effect on current? The resistance is halved from by its actual value. Any answer, Aisha?
Like if you decrease the resistance by half,
Hmm.
I think so it will increase 2 times.
Okay, Aisha said 2 times. Yes, Alvin, you were saying something. Please complete.
Sir, the resistance, it's getting reduced, so the electric current, it will increase.
By which factor? That's the
It is
question.
inversely
If
proportional to the resistance.
I'm saying na ki resistance is getting half, what will be the effect on current? Will it get increase or decrease? By what factor? If you're saying increase, by which factor it will increase?
Increase by half.
Increase by half by Zainab. ठीक है. Alvina?
Increase by half.
Increase by half. No, it will get doubled. Aisha was right. See this thing na? V R by 2. This is a double division. So this will go in the numerator. So that was 2V by R. So this is your actual current. 2I. It is getting twice. It means that if the resistance is getting half, the value of the current will increase by double. Clear? And if the resistance is getting double, the value of the current will decrease by half. Clear, everyone? Okay?
Yes.
Any doubts so far, Alvina, Aisha, and Zainab? Please do let me know if you have.
No, sir.
Sure?
Yeah.
Take it. Now, if the resistance is doubled, the current gets halved. Okay? Any doubt so far to you, which now? Right? And if the resistance is half, the current will get doubled. Clear, everyone? Please do let me know. Okay. So now let's understand the Ohm's law graph. Actually, I was just looking at the sequence that I have followed in the previous batch so that the notes remain same na. So that will be a little bit more organized thing. Okay. So now let's understand the graphs of the Ohm's law. So graphs in the Ohm's law are very important, and it is a topic in which most of the students will get tricked, because the question will be presented in such a manner that you won't be able to like identify that which one is the other graph and which one is the different graph. So there are two graphs, basically both are same, but there is a minor difference in that the change of axis will give you the different values, right? So let's discuss it. Graphs of Ohm's law. Okay, so there are basically two graphs, right? is V versus I graph. ठीक है? Right. So this is another graph that. So this one is B part. This is I versus V graph. Right. So now see this thing, V versus I means this is V. This is I. Okay. So everyone, if the current is directly proportional, potential difference is directly proportional to the current, it means that the line will be a straight line because they are linearly dependent on each other. Right, just like in the 9th class chapter, uniform motion chapter. If the motion was uniform, so the line would be straight. Right. Similarly, if the current, whenever the directly proportional words comes into the scenario, the graph will always be a straight line. Directly proportional means straight line. Is that clear to all of you? Clear?
Yes, sir.
Yes.
Okay, that's great. Now, how many of you know the word slope? Can anybody tell me what do you mean by slope?
The line that's passing through. The line that you're
The
pointing.
line. Okay, this one, na?
Yeah.
Okay, yeah. So that is a slope. Can you tell me the formula of the slope?
Yeah, I don't know the formula.
Okay, anyone? Alvina or Aisha?
Um, Sir, I knew that
Mm-hmm.
it was something minus.
y1,
Okay.
y2, y2 minus y1,
Okay. What about after that,
x2
Mariam?
minus
Something like
x1.
that.
Okay. Okay. Yeah, so you are right, Mariam. Why the in simple words, if I say right now you are talking about 2 points. So in this chapter, right now we are not talking about 2 points. We are just taking a single like a normal general case. So the formula given by Mariam is absolutely right. That is y2 minus y1. It means that the coordinates of y-axis to the x-axis is your slope. Is that clear? So I'm writing y-axis to x-axis. Okay. So as you can see this thing, everyone, the value of y-axis is V and divided by I. Can anybody tell me what is the quantity you are getting when you divide the potential difference by the current? Tell me. Aisha, Mariam, Alvina, Zainab, which quantity? You can take reference from the notes. I'm not saying that you have to just answer me right now. You can take the reference from the notes. I've written this thing in the notes, the start of this topic.
Joule? No, not joule. Is it volt by ampere?
Volt by amp. No, I'm asking about the quantity, Alvina, that you are getting by dividing the potential difference, the current.
Joule by coulomb.
Will get resistance.
Even though you are saying wrong units, potential difference unit is volt and current is ampere. How do you say joule by coulomb? Correct your units, Alvina. Anyone else? Aisha, Zainab, and Mariam. You are telling me the units of the in terms of voltage, in
So
terms
like,
of work done by a charge. Yes,
so
Zainab, you said something.
so like you're asking us like what V by I is equal to
Yes.
resistance.
Yeah, that's correct. That's why I'm
Oh,
saying that please take reference from the notes. V by I is R. It means that the slope of this graph is resistance. Is that clear? The slope given by this graph is the quantity that you will be basically obtaining by the slope is called a resistance of this, basically of the conductor of a material. Okay. So now another thing you can see this thing, if you can see this thing that the slope is there. So it means that steeper the slope, higher the value of the resistance. It means that the steeper the slope, the higher value of the resistance will be in that graph. Clear? In simple words. So more will be the steepness of the slope, more will be the value of the resistance that you will get from this graph. Clear? Is that clear, everyone?
Yes.
Any doubts so far, Alvina, Mariam, Aisha, Zainab? Okay, that's great. Chalo. So I'm writing it here. Alvina, it seems like you have a little bit doubt in your minds. Is it something like MC square cos theta? Something is basically whirling in your mind?
No.
No, no, your expressions are looking like that, so that's why I'm asking. Take care. No issues. The steeper the slope, higher the value of R. Now, the another graph that we have is I versus V, right? So, can anybody tell me what will be the graph of this? I've just discussed it here, like recently, just after like in the last 5 minutes, I was saying continuously about the same thing. Can you tell me what will be the basically the slope type? Whether it would be straight line, curve, or what will be the type of the slope?
Curve.
Yes, yes, Zainab, you said something.
It will be curve.
Okay, Zainab said curve. Aisha, Mariam, and Alvina. It's up to you now. Zainab gave the answer. Fast, everyone. Simple. It's a very simple question. Why are you taking so much time?
Curve.
It will be straight.
Okay, Alvina said straight. Zainab said curve. Aisha and Mariam, let me know the answer.
Straight.
Straight by Aisha as well. Okay, Mariam. Mariam, are you there? Mariam? I think so. She has
Yes,
some
sir.
internet. Okay, no. Yeah.
Sir,
I'm asking
I'm
what will. Okay, okay. What will be the slope type? Straight line, curve? Oh, tell me about the IV graph.
straight line.
Straight line.
Okay,
Yes,
straight
that
line.
will be a straight line. Yeah. Okay, now Zanav has also changed the answer on the words of my words. Yeah. Chalo, no worries. Yeah. So I've told you now that if the potential difference is directly proportional to the current, then current is also directly proportional to the potential difference. That's what I'm saying right now when I was basically telling you about the Ohm's law. Yes or no, everyone? Clear? Okay.
Yes.
So in that case, just a second. So this is your V, so, and this will be your slope. Simple. It will be a straight line. Okay. And here. Slope is equals to again y-axis to x-axis. Now tell me what is on y-axis in this case and what is on x-axis in this case.
Y
What is the
X I is there.
I is there and
Is
x-axis
there.
v is there. Very good. Now can anybody tell me what will be the value you will obtain as in by the ratio of I and v?
1 by R.
Okay, Zainab said 1 by r. Aisha, Mariam and Alvina. Mariam, you have already studied this chapter. Why are you not answering? I'm expecting
1 by
the answer from you. Okay, Aisha, you said 1 by r. Okay, Alvina,
1 by R.
1 by r.
1
Okay,
by
Mariam,
RP.
1 by r.
P.
Why p?
Reciprocal.
What is p
RP
in that?
is the. Oh, no, no, not RP. Just 1 by R.
Rp is the resistance of parallel combination.
Yeah.
Yeah, okay.
Sir, 1 by R.
Yeah, that is 1 by r. In simple words, you can see this thing. V by I is r. So I'm just taking an inverse of it. Okay, so that would be 1 by r. So in this case, the slope is giving you the inverse of r. It means that higher, basically the steeper of your slope will be, lower will be the value of the resistance. It means that the resistance is increasing, but it is in the denominator. So if you increase your denominator of a fraction, the fraction will increase or decrease? Tell me. If you increase your denominator of the fraction, what will happen to the fraction? Will it increase or decrease if you increase the denominator?
It will decrease.
It will
It will
decrease.
decrease. Yeah, that's good. It will decrease because your denominator is higher. 1 by 2 is greater, obviously, than 1 by 4 because the denominator is small, right? So in that case, steeper the slope, lower will be the value of. So that's why student gets confused. Students get confused in this, basically in the graphs. They do not think about whether it's IV graph or VI graph. If the question has given you IV graph, they will ask that which of the following has the lower. So they mark the low, basically the highest resistance as the lowest resistance, because in that case slope will be having smaller. So it means that the resistance will be higher in that case, right? Yes or no, everyone? If the slope is smaller, if the slope is less steeper, so the resistance of that slope will be higher because it is inverse. Yes or no? And the higher, basically, if the slope is more steeper, so in that case, the resistance will be, the ratio will be lower. So that's why student gets confused in the IV graph and the VI graph. Please do let me know if it's clear to you, Aisha, Mariam, and Alvina. Please do let me know fast. Is that clear to you or not?
Yes,
Okay.
sir.
It's important to first analyze the type of graph given to you in the question, whether it's VI graph. If it's VI graph, so simple, you just have to do normal things. But if it's IV graph, so you just have to take the reciprocal of IR. You are talking about the IR. So whatever the highest slope is, it means that the lower will be the value of R in that case. Okay. Now let's talk about the properties of resistance basically. So what basically resistance of a conductor is. So in simple words, the resistance of a conductor is a property of a conductor that opposes the flow of electric current through it. Okay? In simple words, the resistance definition that I have given you in the previous section was based on the potential difference and the current. But right now we are talking about the property. What do you mean by property? In the context of property of the resistance. Okay? Let me write it here. That is a part. Property of a conductor. Due to which it opposes the flow of current through it. Okay. Is that clear, everyone? So next thing about the resistance that we will do in the next class is basically the factors affecting the resistance. Right now, I'm telling you the simple things about the resistance, that what are the factors that affect the resistance. First factor is the length. Second factor is the thickness. Third factor is the nature of the material. Fourth factor is the temperature. Now, temperature affects the resistance. That's why Ohm's law statement says that at constant temperature. Because if you do not take constant temperature, the constant value of R will get changed. That will be not constant. Is that clear? That's why at constant temperature in the Ohm's law is very, very important to write. Clear, everyone? Okay. So let me write it over here. The resistance of a conductor depends on length, thickness, nature of material, and temperature. Okay. Next point about the resistance is, so the SI unit of resistance is ohms. Okay, the SI unit of resistance is ohms. It is basically, so that's the scientist who has given this Ohm's law is based, so that's why the unit is named as ohms. Please do let me know if it's clear to you, bacho. And it is denoted by an omega. So this is the omega sign to denote ohms. Okay. Third, last point about this is, so in the exams, the question comes that define 1 ohm. Right? In the previous topics, we have already discussed 1 volt, 1 ampere, 1 coulomb. So similarly, we are going to discuss this thing in the Ohm's law as well, that define 1 ohms. This is very common. These are the types of very common question that comes in the exam. So let's write it over here. So 1 ohm is the resistance for conductor such that when a potential difference of 1 volt is applied to its end. Okay. And a current is flowing through, current of 1 ampere is flowing through it. So this is the statement of the Ohm's law. Please do let me know, everyone, if it's clear to you or not.
Yes.
Okay, so let's do a question here. So this is a basic question that we are going to discuss on the Ohm's law, right? So let's discuss this thing. This question says that the potential difference of a conductor is 0.1 volt and the current flowing through is 2 ampere. We need to find the resistance of this conductor. Okay? Resistance between the 2 points basically. So we know this thing that V is equals to IR, right? So R will be equals to V by I, yes or no, everyone?
Yes.
V by I. So V is basically your 0.1 divided by 2. So it is coming out to be 0.05 ohms. So this is your answer. Please do let me know, everyone, if it's clear to you or not.
Yes.
Is there anyone who is having any doubt? Please do let me know first. Aisha, Mariam, Zainab.
No, sir.
Chalo, that's great. Okay. That's great. That's great. Okay. So now we have completed the basics of the Ohm's law. In the coming class, will be doing the numerical based on the Ohm's law, and we'll be starting the factors affecting the resistance. Clear, everyone?
Yes.
Okay.
Yes, sir.
That's all for this class. Till then, take care. Bye bye. Allah Hafiz. Good night. And please do the revision. I'll take a Viva in the next class. Huh?
Okay, sir.
Bye,
Thank you.
sir.
Okay.
Allah Hafiz.
Bye.
Thank you.
Allah Hafiz.